Alright, so today I'm going to show you how to use the activity series on a lab exam. Now, I also explained this to you in our lecture practice lab exam that I sent you. So also watch the practice lab exam. That's a good video to watch. So let's talk about activity series and how you use it. So activity series, first of all, will be given to you. You don't have to memorize this. Now, one thing you need to remember about this is that the guys that are on top, they want to be oxidized. So the way that this is put together, the one on top, they want to be oxidized. The one on the bottom, not so much. They want to be reduced. Okay? So top, they want to be oxidized. Bottom, they want to be reduced. Now, the best way to do is to do actually a practice problem. Now, here's the thing. Let's say I have copper plus Sn plus 2 or Sn plus copper plus 2. Now, these two are redox reaction. Now, because you have a redox reaction, doesn't mean the reaction is going to happen, right? It may or may not happen. But when we gave you double replacement reaction, you did ines with ines, outies with outies, you figured out the product, and then you look at the solubility rule, and if everything canceled out, we said that meant there was no reaction. Now here, if you have a redox reaction, how would you know if the reaction is going to happen or not happen? You would look at the activity series. Now, before we do that, you need to figure out which guy is going to be oxidized and which guy is going to be reduced. Let's look over here. Now, copper over here, what's the charge in copper? Any metal by itself, the charge is 0. And I need you to remember this, that when you have a metal that has a charge of 0, metals want to become cations. They want to lose electron. So what's going to happen to the metal? The metal most likely is going to get oxidized. Because if the metal has a 0 charge, right? If a metal has a 0 charge, now what does that mean? So if metal has a 0 charge, that means it wants to become a cation. It wants to lose electron. And when you become more positive, you become oxidation, right? Because oxidation, when you become more positive. Reduction is when you become more negative. So if metal has a charge of 0, it has a charge of 0, then it becomes positive. It becomes cation because metals lose electron. So that becomes oxidized. Because oxidation, you become more positive. So we said copper here is going to become oxidized. Now how about tin? That means tin is going to be reduced because tin already has a plus 2 charge, right? So it becomes tin 0. So plus 2 to 0, you become more negative. That's going to be my reduction. My oxidation, my reduction. Because it already has plus 2 charge. Now it probably going to want to be reduced to 0. So that's going to be my reduction. Okay, now we need to find these two guys on the activity series. Here is tin. And here is copper. Remember, the one that gets oxidized has to be on top, has to be higher on a activity series. Is that a case right here? Is not a case. Here is tin that got reduced. Here's the tin that got reduced, and here's the copper that got oxidized. So the one that gets oxidized has to be higher on the activity series than the one that doesn't get oxidized. I'm going to repeat it one more time. The one that gets oxidized has to be higher up on the activity series compared to the one that gets reduced. That's not the case here because here tin got reduced, copper got oxidized. So copper is bottom compared to tin. So this reaction is not going to happen. Now, let's go to the next one. I have tin here. What's the charge in tin? Hopefully you're yelling at me that is 0. Okay, so if you're 0, if you're a metal, and you're 0, you want to become oxidized because you become a cation, right? And that's oxidation. So if you're metal and you have a charge of 0, metal have a tendency to become cations because they want to lose electrons. So that's oxidation. Now copper over here is going to be my reduction. Copper here is going to be my reduction because I have a plus 2. It can get reduced to 0 or plus 1. Okay. Now here, look over here. Now 10 is my oxidation. The oxidation guy is higher on a periodic table than the reduction guy. So this reaction will be a go. This reaction will be a go. So far, so good. Okay. Now, let's do one more practice problem to make sure you get this down. The next one is H2 plus Ag plus, okay? And H2 plus, let's see, let's go zinc plus 2. So pause my video and do this based on the activity series, which one is going to happen, if any of these redox reactions are going to happen, and then check your answer with me. Okay, now hopefully you did this. Now let's do this again. Here's my activity series, and that will be given to you on the exam. That will be given to you on the exam. Don't worry about that. That will be given to you on exam. Now, if I have H2, and I want you to look at H2 over here. Here's H2 that goes to 2H plus. So when I have H2, it goes to 2H plus. If you remember, on diatomic molecule, the charge is 0, right? On a diatomic molecule, the charge is 0. So here, H2 went from 0 to plus. You become more positive. What is this? This is an act of oxidation. So when you have H2, it's most likely going to oxidize into H plus. So H2 over here has a charge of 0 and is going to become oxidized. Is going to become oxidized. Now here, silver plus 1 is already a cation, so the only option that it really has, it becomes silver, right? So it gets reduced, because Ag plus will go just to Ag. It becomes more negative. It goes from plus to 0. All right, now let's look over here. Here's my H2 and here is my silver. What did we talk about? The guy that gets oxidized has to be on top compared to the guy that gets reduced. Is that the case here? It is. H2 is on top, Ag is on the bottom. Will this reaction go? This reaction will go. This reaction will go. Now, let's look at the other one. Again, the one that gets oxidized has to be higher than the one that gets reduced. Now, next one again, let's do this together. Again, diatomic molecule like H2 and all that, those have an oxidation number of 0, right? It becomes oxidized, you agree, because every time you have H2, it's going to become H plus, so it becomes oxidized. And now, again, every time you have a metal, that metal cation, every time you have a metal that already has a plus charge, most likely it's going to get reduced because it's going to become back to metal. So zinc plus 2 goes back to zinc. And I'm just going to write this down just so you guys... So if I have a zinc plus 2, it's most likely going to go back to zinc plus. And let me write it down here too, just to make sure that you guys are getting this down. So if I have an Ag plus, it's mostly going to go to just Ag 0, right? And that is reduction because you become more negative. Okay, so zinc plus 2 is most likely just going to go to zinc, which means it's going to get reduced. It's going to get reduced. Okay, so one gets oxidized, one gets reduced. The one that gets oxidized has to be higher on an activity series than the one that gets reduced. Is that the case here? Let me find zinc. Zinc is right here. That's not the case here, because here's zinc, here's H2. H2 is the one that gets oxidized and zinc gets reduced. So H2 has to be higher than zinc in order to happen. That's not the case here, so this one is not going to happen. Okay, you have this and you have one on your practice lab exam. Now I want to just tell you one more time to summarize what we talked about. If they give you a redox reaction, is it going to happen or is it not going to happen? You have to look at the activity series. Activity series will be given to you, will be provided on the lab exam. Okay, now you figured out which one has become oxidized, which one has become reduced. And then you go back to the activity series. And the one that gets oxidized has to be higher on the activity series than the one that gets reduced. If that's not the case, then that's not going to happen. Now, last thing, every time you have a metal that has a charge of 0 by itself, that's most likely going to get oxidized because it becomes a cation. Now, if you have a metal cation, For example, here that we had like Ag plus or zinc plus 2, that's most likely gonna get reduced, so it would go back to the metal form. When you have H2 is gonna get oxidized because H2 has a 0 charge. It becomes positive. When you become more positive, oxidation, become more negative, that is reduction. Okay, hopefully you guys got this down.